Right, grade 11s. This last question, question 6, is probably one of the toughest of them. It was also taken from a grade 12 past paper question. So this is kind of like the end goal of where we need to be at the end of next year. So don't stress too much if this is quite a difficult question at this time. Right, so the first question says, question 6.1 says, write down the point of intersection of the two asymptotes of f, and you're told that f is the hyperbola given. Okay, now, even if you wanted to draw yourself a quick graph, you can say to yourself, well, the asymptote moved 2 units right, so that will be at x is equal to 2, and the asymptote would have moved 3 units up, so that would be y is equal to 3. So what is this point of intersection? That point of intersection is when x is 2 and y is 3. So a little bit of a picture helped there. Now this is kind of a stepping stone onto the next question, which is fairly tough. It said the graph of f is translated to form g. Describe the transformation in words if the axes of symmetry of g are y is equal to x plus 3 and y is equal to negative x plus 1. Now this is a fairly difficult question. Basically what they're saying is that there's some graph which is g and it's some transformation of f. And they're saying to you that y is equal to x plus 3 is one of the axes of symmetry. Now y is equal to x plus 3 would go through 3. It would look something like that. And the other axis of symmetry is y is equal to negative x plus 1. And it would go through 1 and it would look something like that. Now, this is where it's really important to understand that the point of intersection of your two axes of symmetry always occurs where your asymptotes hit each other. So my point of intersection of my two axes of symmetry will tell me the asymptotes of this function g. I'm just going to say that again because it's quite an important concept. The axes of symmetry of a function always intersect at the point where the two asymptotes meet. So basically this graph will be somewhere there and somewhere there, and these axes of symmetry are going to tell me what the two asymptotes are. So y is equal to x plus 3 is going to intersect the other axis of symmetry at the point of the two asymptotes. So I want to know, where does y is equal to x plus 3 equal negative x plus 1? So 2x would equal negative 2, x will equal to negative 1, which kind of looks plausible in my little sketch. Now if x is equal to negative 1, I can just go back to this formula, or the other formula, but this one's quite easy. Negative 1 plus 3 is 2. Now that means that I know this point of intersection is at negative 1, 2. Now that tells me that my asymptotes are x is equal to negative 1 and y is equal to 2. Now how does that help me answer this question? Well, if I look at 6.1, in 6.1.1 I actually have the original asymptotes. Now the asymptotes are at x is equal to negative 1. So clearly I can see what transformation occurred. My entire graph and my asymptotes must have been translated 3 units left. So by finding out where the new asymptotes are, I have no idea what this graph looks like, but it doesn't matter. If I can see what happened to the asymptotes, I know what happened to the entire graph. Also, the horizontal asymptote moved down till y is equal to 2, and so clearly it translated 3 units left and 1 unit down. Now that's a really quite a mean question. It is worth 4 marks, but it brings home a really important lesson, and that is these axes of symmetry always intersect where the asymptotes meet. So if you can find the point of intersection of the two axes of symmetry, you know what the asymptotes values are. Right, so that was quite mean. It was a matric question. This was also a matric question, and the reason why I've chosen it is it's just slightly different, and the more you expose yourself to these things, the better. So 6.2 says, a sketch of the graph f of x equals x minus d over x minus p. Now that's very weird. We're not used to this type of format. We're used to something like a over x minus p plus q. So what's happened there? Well, it's clearly a hyperbola, and something has happened, so they've written it in a different format. Now, even if we don't really understand that, we can continue the question, because the question said the dotted lines are the asymptotes of f that intersect at p, and it says that 2, 0 is a point. It's obviously the x-intercept. And the first 6.2.1 says determine the values of p and d. Now, most importantly, even if we don't understand the way it is written, we should know that what causes a vertical asymptote is the denominator. So this asymptote is at -1, so my denominator is going to have to be, my numerator, stays the same. I don't know what d is, it's x minus d, but my asymptote tells me that my denominator has to be x plus 1, because I've moved 1 unit left, and so my denominator has to be x plus 1. Now that means that I can tell you what p is, because this denominator actually represented x minus p. This represented x minus p. So if you want it to simplify to x plus 1, what value for p must be there? -1 must be there, so that the minus and the minus will make the plus. So I know that p is equal to -1. Now, even though I have no idea what's happening in this format, what that means is I now only have one unknown in the formula. It's x minus d over x plus 1. So the only thing I don't know is d. Now, don't forget, even though I have no idea what's going on here, the way to find one unknown is to sub in a point. So when y is 0, x is 2. So I'll end up getting 0 equals 2 minus d over 3, and I multiply by 3 on both sides, and fortunately it makes my life a lot easier, because 0 times 3 is just 0, so I get 0 is 2 minus d, and so d has a value of 2. And so I've figured out the equation of this function, but I've also figured out the values of p and d. Now notice it was only 2 marks, because it was slightly weird, and being able to see the value of p, you would just get a mark for p is equal to -1. It could possibly have been worth 3, one for subbing in the point and then finding d. But I think they made it 2 marks because it was fairly mean. Right, moving on to the next question. Show that f can be written like that. Okay, now finally, that's what I'm used to. So what have I got so far? So far, I've got the fact that f of x is x minus 2 over x plus 1. And I'm meant to show that that and that are the same thing. Now there's 2 ways to do this. Either we can start with this equation number 1 for f. Oh, that's a terrible color, let's change it. Either we can start with equation number 1 for f and show that it's the same as equation number 2, or we can show that 2 is the same as number 1. Now I don't know how to take this particular format of the hyperbola and to kind of split it out, and so the easiest thing would be to do is to start with y is equal to -3 over x plus 1, and how do I combine those 2 terms to get one term? Well, how do I combine fractions? I need an LCD. So this is -3 over x plus 1 over 1. And if I want an LCD, that LCD is going to be x plus 1. So this would be -3, but what you do to the bottom of a fraction, so this is times x plus 1, so this is times x plus 1, so this is plus 1 x plus 1. And so now if I neaten that up a bit, I'm hoping that I'll get the other format. So y equals -3, so it's plus x plus 1. 1 take away 3 is a -2 over x plus 1. And what do you know? That's exactly what I meant to have. So the easiest thing to do here would be to take how it was written in the format they gave us in number 2 and just show that if I combine those fractions, I got the same equation as that I already found. Now again, that's fairly mean, very unseen, something that probably would have thrown them. Now don't forget, even if you were thrown by 6.2.1 and 6.2.2, they've now given you the equation. So it means that I can continue with the rest of the question and I mustn't get thrown by it. Because the next question says find out the coordinates of p. Now this should be a really easy question for us now. because now I know that this graph is y is equal to negative 3 over x plus 1 plus 1. They told me that. So even if I didn't know that, it was given to me. So now I can find the values of p. I know that that asymptote is at y is 1, and so p is the point negative 1, 1. So that's 2 marks that don't let the first 2 questions throw you off for those marks, because those were completely attainable once they'd given you the equation. Next one's a little bit weird. Write down the coordinates of the image of B if B is reflected over the axis of symmetry, which is y is equal to x plus 2. So where's B? B's there. Now where's this axis of symmetry? My axis of symmetry would be there. Now I think the easiest way to do this is just think to yourself, axis of symmetry means I need to fold this point over that line and land up at another point. Now obviously this isn't drawn to scale, so I can't just look at it, but let me ask myself, how far did I go across and up to get to P? Because however far I went across and up, if I just go across and up again, I will get to the reflection on the other side. So let's have a look. My x value was 2, and this x value is minus 1. So clearly I subtracted 3 to get to P. So I'm going to subtract 3 again. So P has a value of negative 1, 1 as its coordinate. So if I look at B, B was the point 2, 0. If I'm going to P, which is the point negative 1, 1, and then I'm going to go to the reflection, which we would generally call B dashed, what I'm saying is if I look at this x coordinate, I subtracted 3. So if this is going to be a reflection, I must just subtract 3 again. So negative 1 take away 3 is negative 4. And I can do the same thing for the y value. How far did I move up? Well, this y value was at 0 and I went up to 1. So I moved up 1, which means I just need to move up 1 again. So that's 1. And so there's B dashed. Now again, that would be considered really problem solving. This was one of the meanest questions in that particular matric exam. And so definitely don't get thrown off by the fact that these questions were quite tough. It's important for us to expose ourselves to as many types of questions as possible, because that's how we get good at these types of things. Right, I think this is the last question, 6.3. It says, the exponential function, which is given to us, it's told me I have a base of 2, which immediately means if I just quickly draw it, it means I do that. I'm increasing. I don't know what q is, so I could have moved up or down. Now it says it has an asymptote at y is equal to 1, which clearly means my graph must have moved up 1. So actually my graph needs to look like that. It also says it passes through the point 0, minus 2. And then it says determine the range of G. Well, to be honest, only problem here is, which is something I should have thought about, I think it looks like that, but I don't know what P is. So it could look like that, but it could have also got folded downwards, in which case it'll look like that. So I clearly know that my range has something to do with this y is equal to 1. So it's either y is going to be greater than 1, or y is going to be less than 1, depending on whether it actually lands up being the yellow graph or the blue graph. So let me raise my orange graph. Those are my two options. It's either the yellow graph or it's the blue graph. And depending on which color it is, I'm going to get a different answer. So I need to know, is this an increasing yellow graph or is this a decreasing blue graph? Now the only way to do that is to figure out P. I need to know, is the P value positive or negative? So let's look at what we know so far. So far I know it's P times 2 to the power of x, and I know this is plus 1. Now they gave me a point on the graph, so y is negative 2 when x is 0. Now anything to the power of 0 is 1, so this is P times 1, just P, and I get P is negative 3. Now the moment I know that P is a negative, it cannot possibly be that graph, which means my graph is the blue one. And so I now know that my range cannot possibly y is greater than 1. My range must be y is less than 1. Not equal to 1, because that's an asymptote and it can't get there. So again, fairly problem-solving question. So all in all, I think that's the end. All in all, question 6 was quite tough. Definitely the meaning of the questions, and as I've said so many times before, the more we expose ourselves to these types of the questions, the more confident we get with functions. Okay, we're definitely going to do a mixed revision on all of the functions together because it's all about practice, practice, practice. So we'll pick it up then.